So details of machine wise are shown in figure. Assemble the parts and draw the following views of the assembly. So there are two views asked in this question. So this is about machine wise drawing. So the figure shows the parts of the machine wise. So bill of material is also shown here. So totally there are 9 parts. So name of the part, part number, material and number of parts required is mentioned in the bill of material. So the views of each parts are given. Referring these details, we need to draw the assembly drawing. So now I will show how to do manual drawing of this machine-wise assembly. So the 3D view of the machine-wise is also shown here. So it contains fixed jaw and movable jaw, and there is a screw rod. The screw rod is operated. The movable jaw makes a to and fro motion, and thereby it fixes the object between the jaws. So for the manual drawing, so here there are two views asked. One is the front view showing a right half section, so that's right portion in section. Remaining portion is just the side view, and top view is also asked. So the procedure goes like this. Okay, so I will show with it's a A4 sheet. Actually it's not suggested to do it on A4 sheet. Bigger sheet is recommended. A2 is recommended. Since because of this constraint here, I will just this video is just to explain the concept how to uh, do the assembly drawing. So that's why I'm just showing with the A4 sheet. Okay, I suggest to practice this on A2 sheet with the mini drafter. Then you'll get a good feel of drawing. So this is the bill of material. So totally there are 9 parts. Part 1 is the body of vise, movable jaw, jaw grip, so screw, M6 screw, screw rod, washer, nut, lock nut and clamp plate. So the material is also mentioned. Material of each part is also mentioned. This is bill of material. So I will show the parts and their views. So this is the part 1. Okay, so part 1 is the body. There's so three views are given here. So this is the front view, and then top view, and left view is shown in this. Okay, along with these details. Okay, so this is the body. So movable jaw is shown here. This is the movable jaw. Okay, which makes to and fro motion. The screw rod uh, is inserted in this, and when the screw rod is operated, the movable jaw makes a to and fro movement. So this is movable jaw. So screw rod drawing is shown here. So this is the screw rod, details of screw rod. So front view and top view. Then with the clamp plate, washer and M6 screw. So this is the Two views of clamp plate is given. Along with this, part number 9 is a clamping plate. Part number 4 is M6 screw, and then 6 is the washer. The section view is shown for the washer M6. And this is the drawing of jaw grip. This is the jaw grip. So which will be attached to the fixed and movable jaw. So the details of jaw grip is as shown. So now I will do the assembly drawing of this. So first is the body. It start from the body part. Okay. So if this is very small, you can refer the hard copy provided. So on screen it looks very small, so I suggest to people to refer the textbook for this. So the drawings asked here in this is assembly drawing. Assembly drawing. First one is front view, and then top view. Side view are not taken because the space is not sufficient. I can't fit in the sheet, so that's why I'm taking only two views. So I suggest you people to do this assembly drawing on A2 sheet. So with the 2:1 scale, then it will look very nice along with side view. Okay. So front view and top view. So front view with right half inch section. Right half inch section and top view without section. Okay, so this is what is required. Okay, so two views. So to fit this in the sheet, I will take the sheet like this, portrait. So two views will come here. So front view here and top view. So no side view. I'm not trying side view. Okay, so front view and top view. So it is not possible to fit this drawing to 1:1 scale. Not possible. So I will make it 1:2 scale. Okay. So taking scale 1:2. Scale is 1:2. Okay. So it is. I will leave more space for top view because so it's top view it's wider. Okay, so that's why I keep more space for top view. So I'll start from the front view here. Front view of the machine wise, body of the machine wise. Okay, so this is XY line. So length is 230. Then okay, so it is 230 and then 5 mm step on either side. Okay, so total length is 230. So 230, so 220, so it is um, 110. Up to here I will take this dimension 110. I will hide this side view for time being. Okay. Height is 57 mm is the height. 57 means 27.5. Sorry, it is 28.5. 20, 20, 10, 20, 28.5. From here I will draw a horizontal line. This is just for reference. Okay, on this end, from here the height is 85, that is 42.5 from this end, 42.5. So it is up to here. And then this width is given, it is 40 mm, 35 mm. So 35 mm, 17.5 here. So it is 17.5 mm comes up to here. Then 12.5. Up to here. Okay. And then 2.5 mm step here up to here. Okay. So then vertical step. Okay, so it is up to here. And here it is a fillet of radius 10. Okay, so it is half is 5 mm. So use pro circle for this purpose. It is very difficult to draw using compass, so use pro circle. Measuring 5 mm on from the corners, I will draw a rectangle here. Sorry, square. So now this is the center. And then I will draw a arc. So you should locate the center and then draw the arc. So like this. Then the axis of the screw rod, it is at a height of 30 mm. So this is the axis of the screw rod. Screw rod will come here. I will just draw the screw rod. Axis of the screw rod. I will, while assembly, I will show the screw rod here. Then there is a step there that is its thickness is 5 mm, so it is 2.5. So 2.5. 2.5 here on this side. Okay, and the diameter is it is 32, so 16 means 8 on either side. Two 2.5 mm from here. Measuring 8 mm on either side. So it is 30 to 16, so 8 mm here also. Um, okay, and it is very small step, so I will just draw and curve. Okay, so radius is given, it is R5 actually. R5 use pro circle for this. So this is the front view. Okay, so if I take the section, I need to show the sectional view in front view with the right half inch section. So here so hole is also visible where the screw rod will pass through. So diameter of the hole is it is given in the side view. Okay, so it is the diameter is Diameter of the hole is 20. It is from here up to here. So yeah, up to here we can see this hole. Then screw rod will pass through this hole. Oil hole is also visible. It is at a distance of 20 mm from this end. So I will take 10 mm. So oil hole, it is up to this length. So it is so diameter is 3 mm. So show hole of hole of diameter 1.5 mm. Okay. Okay, so from total length is 110. I will take half section, so it is up to here. Here it is this portion. So right portion is in section. So I will just draw a reference line. So this portion I have to show with section. So this portion without section. So here it's 15 mm, 7.5 mm. This I can't see, so it should be a dotted line like this. And then there is a hole here. So diameter of the hole is it's not it's mentioned. Okay, so it is 12 mm diameter hole. So it is 3 mm. Okay, the screw rod will come here. So directly write the screw rod. The screw rod. So M10 at the end it is threaded. It is M10. So that the 12 mm step will go inside. So outside projection will be 22 mm. So I will start from this end. So here it match with this end. So from here it is 40 mm. It is 20 mm. 20 mm this side, 20 mm here this side. Okay. So connecting this to it is not sharp corner, it's a radius 3. So radius here it will become 1.5. So I can't draw that, so I will just make it draw by freehand. Okay. So but in software you make use of fillet option. Fillet you give this edge radius 3. Then there is a hole here, so the radius of the hole diameter is given. It is given in the top view. Okay, so the radius is 5 mm, diameter is 10 mm. So it is at a distance of 20 mm from this end. So that is 10 mm from here. So this is the center, and so draw a circle here. The diameter of the hole is 10 mm. Then this 40 mm length that will come up to here. 40 mm means 20 is up to here. Okay. So is 10 and then further it will extend to a length of 170. 170 means 85 mm. 85 mm length screw rod, it will match to this edge. So up to here I will show with the thick line, then it is a dotted line because this portion is without section, so it is dotted line here up to here. Okay, and then similarly I will to here I will show the section of section. So here I will make it dotted line. And then it is 12 mm. So 12 mm means here and so okay. So this is the screw rod. Show with the dotted line. Okay. So then 10 mm step. Because of that only I'm saying it is not a common factor, right? Now when you make this equation, now it becomes a common factor, right? In terms of delta state, delta S is nothing but this plane. So this is a procedure. The earlier procedure, what I've done there is wrong actually. So it is nothing but delta S. So delta S is in the morning session we are saying it projects out we have written this equation. Please go through the morning for 18 mm. So that means 9 mm. It is up to 9 mm here. So press sign comes because it is because this steel will be in tension and this gunmetal will be in compression state. So okay, so that M10 projects out which is to a length of 22 mm, so it is 11 mm. So this 11 mm up to here. Okay. So So this is threaded M10 where the nut will come here, and this is threaded region. I will show actually not required because nut will come here. So this region I need to show with threading. Okay, so please refer thread chapter for drawing and for showing threads here. Since it is very small diagram, I am just drawing like this. You need to take measurement and draw and to show the thread. Okay, so this is the screw rod. So the hole will come here. Use pro circle to show the hole here. The diameter of the hole is here it is 5 mm. So I will just write like this. Okay. Okay, so nut will come here. So I will take. I will hide this. So take nut drawing. Just a minute. Okay. So the thickness of the nut and width, it is the distance between the corners is given. It is 18.72. I will take that distance here. 18.72. Width is also given here. So it is 18. 5 mm and 8 mm nut. So drawing nuts here. It is 8 mm. It is 4 mm and 4 mm and 2.5 mm. So 4 mm and 2.5 mm. 2.5 approximately here, and it is distance is sorry the width is 18.72. That is so 0.5 approximately first distance here. Okay. To show the nut like this. Okay. And okay, so this is the these are the nuts. Load is 33,841 divided by area of the conductor is 498.87. It is already determined in this step number, on this step 2, it is equal to 68.94 Newton per mm square. Is it clear? Sorry, I made a mistake here. Okay, so it's not correct actually. Which is also equal to 1 megapascal. What is 1 megapascal is nothing but 1 Newton per mm square. So you can even express the answer in Newton per mm square or Newton per meter square or megapascal or bar. So whatever is convenient, you can express the answer. Is this clear now? Yes. 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 So now what they are asking is what is the increase in length of the what is the second question? Okay. This is stress developed in the rod and tube in the temperature. Also find the increase in length. The original length of the assembly is 1 meter. Right? Okay, so this fillets make it freehand drawing. Hello. Yes, so not fillet actually, it is chamfer. Chamfer of the edges of the nut. So after chamfering, the views of the nut looks like this. Okay, so that is 30-degree chamfering of the ends of the nut. It looks like this. Okay, so next is movable jaw. So movable jaw will come somewhere here. Okay, so before that I will draw jaw grip. So this jaw grip is the thickness of the jaw grip is 8 mm. Okay, so is 8 mm and the height is 28 mm. So jaw grip will fit here. Jaw grip will fit here. So it is 4 mm. So little more it will project out from the slot. So from here um, it is 28 means 14 mm. 14 mm up to here. Okay, so this is the jaw grip. We can see this portion because this is section region, and then should show with hatching here. This portion should be shown with hatching. So draw 45-degree line, and it should be thin. Here I'm making thicker, little bit darker because it has to be seen in the camera, so that's why I'm making a little bit darker. Actually it should be a thin line. Okay, so this is so fill this region with hatching like this. What is this value? You check it. I think you will be getting the same value, 2.847. You can check it. Hello? You please check this. Yes? Yes. That is due to tensile strength. That is nothing but PL by AE, man. PL by AE. So P by A is sigma S, L by ES. This is there due to temperature. This is elongation of the steel due to temperature. And this is jaw grip also. We need to show the section. I will. That should be shown with the different style of hatching because it's a different part. So in assembly, the adjacent part, if someone look at the assembly, he should be able to make clear differentiation between the clearly identify the parts. So that's why. So we should differentiate them with the style of hatching. So adjacent parts should not have same style of matching. Either so uh, make it so that it looks different. Okay. So here the jaw grip is different. So this I made it 45-degree like this, and this in opposite direction 45-degree, so that easily we can identify that this is a separate part. So that's the objective actually. So Yeah, so this region we can't, you need not to hatch because so it is a hollow inside. Inside it is hollow slot. So that's why, so don't hatch here. Okay, so only this part should be hatched. So now this is the screw rod. Don't show hatching for screw rod also. For screw rod also you should not show hatching. Okay. Yes, yes, you please check this when you take the calculator and then you check this whether you are getting the same, whether you are getting the same value or not. So in this case, so you can take with respect to steel or with respect to the gunmetal. In the case of the gunmetal, this will be minus sign. So the job grip detail I need to take once again. So now it is a movable jaw. Due to temperature. Elongation of gunmetal due to temperature. Gunmetal due to temperature. And this is elongation of the gunmetal. This is compression of the. So movable jaw here. I need to assemble movable jaw over this. Okay. So it depends on the distance between the movable jaw here. So I will take some convenient distance. I will take 50 mm. Okay, 50 mm distance from distance between the jaw. Distance between the jaw. I will take 50 mm, and I will draw or show jaw here. Okay. So here I need to start from the jaw grip. So I will align this dimension. Align this dimension here. So its thickness of the jaw grip is 4 mm. So it is 4 mm here like this, and then on top side also it is 4 mm. Okay, so this is the jaw grip. Yes. So we'll do one more problem. Okay. A composite bar. Get on the next problem. A composite bar. This is the jaw grip, and so I will just check whether the height is same or not. It will be same actually, I think. So it is 25 mm. And okay, so I will start from this and taking from the jaw grip I will take so distance of 35 mm. So 35 mm means no, from right. Okay, so it is 35 mm, 17.5 mm, 17.5 mm from here. Okay. So 10, 15, 16, 17.5. 17.5. From here I will draw a vertical line. As shown in the figure. The bars are stress free. The bars are stress free. The bars are stress free at a temperature of 42 degrees Celsius. Are stress free at a temperature of 15, 16, 17.5 to here. So then from here it is a 50 mm from this end. 50 mm is 25 mm from this end. Okay. So 25 mm from here, 10, 20, 25 mm. Okay, so take care while drawing this, because you need to take measurement from the jaw grip. Jaw grip will fit into the slot and the slot space is 5 mm, but the jaw grip thickness is 6 mm. Okay, so it 1 mm, it projects out by 1 mm. So take care of that. So there's a small 1 mm gap here. Okay. And then from here it's is 1.5 mm. Yeah, it's 1.5 mm thickness here. Okay, and this is of radius is very small, radius 3 mm. So I will just make it like this. Okay, and then here radius is 5 mm. This, so need to locate the center of this arc. So take 5 mm from this side, horizontal and vertical. 5 mm, draw a square, and then you will get that corner as. So this is this is how you need to draw the arc. You should identify the center of the arc and then draw. Okay. So here it will be a dotted line. Now this is the question. Please copy the question. So it is a composite section. There are two materials. One will be dotted line like this. The length of the first part is 500 mm and length of the second part is 250 mm. And these are the given data. Okay. From here also. All these are given. Right. And so it is. Drops down from 42 degrees Celsius to 24 degrees Celsius. The screw rod will pass through the movable jaw. Okay. So by operating the screw rod, jaw makes front and back movement. So, in orthographic view of the movable jaw, the top one is the bottom view of the jaw grip. Sorry, movable jaw. So, identify the location of the holes. There are two holes of diameter 5 mm and depth 15 mm, and also it is a threaded hole, M6 threaded hole. The thread is up to depth of 10 mm. So the distance of the hole is should match with the clamp plate here. So I will take the total height is 45. It is given, so it is 45 mm from the lower end of the top portion of the movable jaw. So it is 22.5. So I will measure 22.5 from here. It is 20 45 to 22.5. So it is 22.5. So here comes the clamp plate. Clamp plate is assembled here through this vertical hole. Okay, so the holes in front view we can see one hole, the other hole will be behind that hole. So it is at the center here. So this is the axis of the hole. Okay, so this is about the front view. It's not completed. You need to show the dimensions and annotations. Part numbering also should be shown here. Okay, so then um, we say that drawing is complete. Okay, so the view is like this. So this is the front view of machine wise with right half in section. Okay, I will show like this, you can understand. So this is the front view of the machine wise. Okay, so this is the head of the screw rod. Screw rod continues here, and it is threaded actually here. So up to here you can see I have taken half portion. So total length is 110, actually 220, 110. I taken exactly at the center, this right portion with section like this. Okay, so, and then the screw rod end of the screw rod with the nuts and lock nut. This is also threaded, so you should show thread at the threading also should be shown at the end here. So this is threaded region. So like this. Okay, so this is the front view of the machine wise. Now how to draw the top view of the machine wise. So I'll take projection from the front view, so it will be easier if you take projection. So I will go for the drawing of the body. So top view of the body like this. I will take the projection from the ends. So total width is 180. So for 90 mm, 45 on either side. So this is the center line. I will just draw a reference line here. So this is the reference line. It's measuring 45 mm on either side. I will get I'm getting this distance 90. Okay, so from here to here. So this is just a reference line. You will just for reference. I need to erase this afterwards. It's just for reference. Okay. So now in this taking projection from the uh, projections of this jaw. So it is one more boundary I need to draw here is it is 100 mm. Oh, sorry, I took 35 instead of 45. Sorry. Okay, so let it be. Later on I will do that. Okay, so it is okay, so this is what is required actually. So like this. Okay. So this is not required. Okay, so now taking projections from top view here. For the jaw grip also. Okay, so this is jaw grip, and oil hole will come here. So I will just draw a circle here. Okay, smaller circle. That's the oil hole, and then projection on either side. Either side here and this side. Okay, I will copy the dimensions. So it will be easier if you use compass. Okay, so need not to measure. So you can just copy the dimensions like this. Or you can use scale for measurement also. Okay. So showing the screw rod here outside, it is 12 mm, and so it is like this, projected out a bit. So I will match with this dimension. Okay. So it's like this, and then the nuts, and here, so two nuts. In front view it appears like this, but in top view it appears as two rectangles. So I need to show like this. So the net drawing so net drawing, it is given that distance between flat ends is 17. Okay, so in so 17 mm, 17 mm means 8.5. So 8.5. So it is up to here. It appears like this in top. I will erase this portion because it will appear as rectangles, two rectangles. So I will show rectangle shape. Okay, and you need to show chamfer by drawing the arc. Okay, so please refer thread forms chapter and hexagonal nut and bolt chapter. Okay, so here I will just draw freehand curve to show the chamfering like this, and then it is chamfer and screw. I will show like this, and then this will appear as a cavity here. So take the reference line here, it up, so you can see that slot inside that is shown here. It is 40 mm, so 20 mm on either side from the center line. Sorry, yeah, it is 10 mm in this case because this is 1:2 scale, so 10 mm on either side, and it will be up to this end, and like this can be seen here, but in the region of movable jaw grip you should show the jaw grip here. There it is not visible, and you can see this slot like this. So and it is a small fillet here in this corners. Okay, so this is the so top view of the body, and the screw rod also I need to show. Screw rod is screw rod will pass through this axis of this hole, and so it is here in this region. 0.216. That is a second step. Okay, when you come to the last part of the question, what they have said. Because the top view, you can see the threads in this. I need to show threading. It is threaded along this line, so show the threading here and here also. Show threading here. This is the top view of the mobile jaw. So mobile jaw. So it will be this line and then this line. Okay, so this is the mobile jaw. So the portion inside that mobile jaw, portion of the screw rod inside the mobile jaw, that should be erased or make it dotted line. It's not visible. So this should be a dotted line. So this, if you yes, hello, can you hear me? Yes, this portion will not be visible because the like this. And then here the head of the screw rod. So in top view also there is one more hole. Okay, so this hole is visible in, I mean another hole. So two perpendicular holes will come here. Okay, so one like this horizontal and one more vertical. Okay. So to show the hole here also. It's not coming properly. Okay. Yeah. So measuring 115, that is one 110 from here. 110 means 55. Okay, so 55, measuring 55 from this end here. This is where I need to draw the projections here. This is for the assembly purpose to mount the machine wise. So this projection is provided. And it is up to from the center, it is from center here it is 245 mm here. Okay, so total is 180, so 45 mm on either side. So like this here. Okay, so from center measure 45 mm and mark, so it should come here, somewhere here. Okay, so now the dimension of the slot is so it is, yeah, it is mentioned Okay, so uh, radius 8 and radius 13 I need to mark here. So from the center it is 4 mm on either side here, 4 mm and 4 mm. Uh, 4 mm here. Okay, this is 4 mm. Because you are not taking the phone or you are not attending the call also to inform regarding the project. Hmm? Yes, sir. No, no. Even if you are busy now, 13 means 6.5 mm. 6.5 mm here. 4 and 6.5. Okay, similarly, I will copy the dimension here. It is 4 mm on either side, 4 mm and 4 mm, and then 13 means 6.5 mm, so 6.5 mm also 6.5 mm. Okay, so like this, I just the mark the reference points. Now, so the distance is given. It is 154. 154 means it is 77 77 mm. 70, 77 and of 77 is 35 38.5. So measuring 38.5 38.5 here, on this side also 38.5, like this. So this is reference here, and drawing these lines up to here. Okay, using compass and drawing the arc, it is very small. It's very small arc. Arbas, you please don't read. You should not read it. You just give what is that, right? It is already available. Yes, yes, sir. Yes, yes. You come to objectives. Yes. Okay. Right. So I'm showing like this. Okay. So this is the position of the okay, it is the distance of 13 mm. So okay, so 6.5. Right. So now the total width of um, this slot for the support, that is 120 mm. So from the center, so 120 means it is 60 mm. So I'll take 30 mm on either side. So from here it is 30 mm, 30 mm on either side. Okay, so it is this distance 30 mm here, and then 30 mm here. Okay, so from the top, it is given that radius is 13. First, I need to locate the center. It is at a distance of, along this line, it is at a distance of 10 mm. So 10 mm here on this side and 10 mm on this side here. So similarly, measuring 10 mm on either side, it is this point and this point. Okay, so from here I need to okay, so this is for the center of the arc. So first I will draw a reference line. So here also I will draw the reference line here. Okay, so and then measuring 6.5 mm radius, so very small arc, so difficult to draw this. So that's why I suggest you people to draw to 2:1 scale. It will be very good if you draw to that scale. So I located the center of the arc. This is the center of the arc, and drawing like this. Okay. Similarly arc from here like this. So connect these points by drawing a tangent line. So should be a tangent line to this. So similarly, drawing a tangent line to this end here, and then like this.
One minute, 1 minute. What is that, man?
Okay, so this is the top view of the machine. Yes.
What is that map? You have received the last one, right? WARE, what is that? Okay, fine.
Okay. I'll make this visible.
What you have
Okay, so this completes the front view and the top view of the machine wise. I'll show like this. Okay, so front view and the top view of the machine wise assembly. So like this. Okay, so still I don't think it is complete. Still the dimensioning part is also important. That is not done here. You should show the annotations and the bill of materials. Those things should be included in the drawing. Okay, so thank you for watching this. Thank you.
Yes, sir.